Have you ever looked up at a rocket launch and wondered why it's painted white? It seems like a simple question, but the answer is rooted in fascinating science and engineering. The choice of white paint is not arbitrary. It plays a crucial role in a rocket's performance and safety. Painting a rocket is a significant expense, both in terms of materials and labor. To understand why white paint is so important, we need to consider the extreme conditions a rocket experiences during launch and spaceflight. One of the biggest challenges is heat. As a rocket ascends through the atmosphere, air friction generates intense heat. Once in space, the rocket is exposed to the full intensity of the sun's radiation, with no atmosphere to filter it. This is where white paint comes in. White is highly reflective, meaning it reflects a large portion of the sunlight that hits it. This reflectivity helps to keep the rocket cool by reducing the amount of solar radiation absorbed. Think about wearing a black shirt on a sunny day versus a white shirt. But the benefits of white paint go beyond just temperature regulation. White is also a highly visible color, which is important for tracking the rocket during launch and ascent. Additionally, the bright white surface makes it easier to spot any damage or imperfections on the rocket's exterior. This is crucial for ensuring the safety and success of the mission. Section 5. A historical canvas white rockets through time. The use of white paint on rockets has been a common practice since the early days of space exploration. One of the most iconic examples is the Saturn V rocket, which carried astronauts to the moon during the Apollo missions. The Saturn V's massive white body was a testament to the importance of reflectivity in managing the extreme temperatures of spaceflight. Other notable examples include the European Space Agency's Ariane 5 rocket and the Russian Soyuz spacecraft. Section 6. The Space Shuttle, a spectrum of purposes. While white is the predominant color for rockets, some spacecraft have incorporated other colors for specific purposes. The Space Shuttle, for example, featured a distinctive black heat shield on its underside. This black material was designed to absorb the intense heat generated during atmospheric re-entry. The rest of the shuttle's body was primarily white, reflecting sunlight and keeping the interior cool. The contrasting colors of the Space Shuttle highlight how paint can be used strategically to address different thermal challenges. The choice of colors on the Space Shuttle was not merely for aesthetic appeal, but served critical functional purposes. The black heat shield tiles made from reinforced carbon were essential for protecting the shuttle from temperatures that could reach up to 1,650 degrees Celsius during re-entry. These tiles were meticulously designed and tested to ensure they could withstand the extreme conditions of space travel. On the other hand, the white paint used on the rest of the shuttle's body was chosen for its reflective properties. By reflecting sunlight, the white paint helped to maintain a stable temperature inside the shuttle, preventing it from overheating in the harsh environment of space. This careful consideration of color and material was a testament to the ingenuity and precision of the engineers and scientists who designed the space shuttle. Each decision, down to the color of the paint, played a vital role in the success of the missions. The space shuttle's design demonstrates how even the smallest details can have significant impacts on the performance and safety of spacecraft. The use of different colors and materials to manage thermal challenges is just one example of the many innovative solutions developed by NASA. As we continue to explore the cosmos, the lessons learned from the Space Shuttle program will undoubtedly inform the design of future spacecraft. The strategic use of color and material will remain a crucial aspect of space exploration, ensuring that our journeys beyond Earth are as safe and efficient as possible. In conclusion, the Space Shuttle's use of a spectrum of colors highlights the importance of thoughtful design in addressing the unique challenges of space travel. From the black heat shield to the white reflective paint, each element was carefully chosen to ensure the shuttle's success and the safety of its crew. Section 7. Beyond white: new materials, new possibilities. As technology advances, new materials and designs are emerging that could potentially reduce or eliminate the need for paint on spacecraft. One promising development is the use of lightweight composite materials that have inherent thermal properties. These materials can be engineered to reflect or absorb heat as needed, without the need for additional coatings. Another approach is to use active cooling systems, such as those employed on the International Space Station, to regulate temperature. Section 8. SpaceX's Starship, a gleaming vision of the future. SpaceX's Starship, a fully reusable spacecraft designed for interplanetary travel, is a prime example of this shift towards new materials. Starship's exterior is made of stainless steel, which is naturally reflective and highly durable. The gleaming, unpainted surface of Starship is not just aesthetically striking, it also offers practical advantages in terms of thermal management and longevity. This innovative design suggests that future spacecraft may not rely on paint to the same extent as their predecessors. Section 9. The economics of color balancing cost and performance. The choice of whether to paint a spacecraft or use alternative materials often comes down to a balance of cost and performance. Painting a rocket adds weight, which can increase launch costs. Developing and implementing new materials and cooling systems also requires significant investment. However, these upfront costs may be offset by long-term savings in fuel and maintenance. As space exploration evolves and missions become more ambitious, the economics of spacecraft design will continue to play a crucial role. Section 10. Painting the future. Will white remain supreme? So, will white paint continue to be the go-to choice for rockets in the future? This question has intrigued both engineers and space enthusiasts alike. The traditional white paint has been a staple in the aerospace industry for decades, primarily due to its practical benefits. While white paint remains a practical and cost-effective solution for many current missions, it serves a crucial role in reflecting sunlight and minimizing heat absorption. This is particularly important for maintaining the integrity of the rocket's structure and the sensitive equipment it carries. However, the emergence of new materials and technologies suggests that we may see a more diverse palette of colors on spacecraft in the years to come. Advances in thermal coatings and materials science are opening up possibilities that were previously unimaginable. Ultimately, the optimal approach will depend on the specific requirements of each mission. For instance, missions to Mars or other distant planets may benefit from different color schemes or materials that better suit the unique environmental conditions they will encounter. Factors such as the destination, duration, and scientific objectives will play a significant role in determining the best design and color for a rocket. For example, a mission aimed at studying the Sun might require a different thermal protection strategy compared to a mission heading to the icy moons of Jupiter. Whether it's the classic white of the Saturn V, which became an icon of the Apollo missions, or the gleaming steel of SpaceX's Starship, each design tells a story of its time and purpose. The Saturn V's white paint was not just for aesthetics. It was a functional choice to protect the rocket from the intense heat of launch. The design and materials of spacecraft will continue to reflect the ingenuity and ambition of our quest to explore the cosmos. Engineers and scientists are constantly pushing the boundaries of what is possible, experimenting with new materials and technologies to improve the performance and safety of rockets. As we look to the future, it's exciting to imagine what the next generation of rockets will look like. Will we see vibrant colors that signify different missions or new materials that offer unprecedented levels of protection and efficiency? Only time will tell. One thing is certain, the evolution of rocket design will continue to captivate our imagination and drive our pursuit of knowledge. Whether white remains supreme or gives way to a spectrum of colors, the ultimate goal remains the same, to explore the vast unknown and push the boundaries of human achievement. As we stand on the brink of a new era in space exploration, the choices we make in rocket design will reflect our aspirations and our commitment to advancing human knowledge. The future of rocket colors is not just a matter of aesthetics, it's a testament to our ingenuity and our relentless pursuit of the stars. Section 11. Conclusion. A palette of possibilities for space exploration. The seemingly simple question of why rockets are painted white opens up a fascinating world of science, engineering, and innovation. The color white is not just an aesthetic choice, it plays a crucial role in the thermal management of the spacecraft. White paint reflects sunlight, helping to keep the rocket cool as it travels through the intense heat of the Earth's atmosphere and the cold vacuum of space. From the extreme temperatures of space to the economics of launch costs, the choice of color is a critical factor in spacecraft design. The white paint helps to minimize the thermal stress on the rocket structure, ensuring that the materials can withstand the harsh conditions of space travel. Additionally, the cost of painting a rocket is not trivial. The paint must be lightweight and durable, adding to the overall expense of the mission. As we push the boundaries of space exploration, we can expect to see even more creative and sophisticated approaches to thermal management, materials science, and the aesthetics of our vessels. Engineers and scientists are constantly researching new materials and technologies that can improve the performance and safety of spacecraft. For example, advanced composites and coatings are being developed to provide better thermal protection and reduce the weight of the rocket. The future of space travel is bright, and it will be painted with a palette of possibilities. As we venture further into the cosmos, the design and appearance of our spacecraft will continue to evolve. We may see rockets with new colors and patterns, reflecting the diverse and innovative spirit of space exploration. The possibilities are endless, and each new mission brings us closer to unlocking the mysteries of the universe.